Hello, we'll talk about optical device, some optical device in this time. First, LED. LED means light emitter device. We learned about PN junction diode in last. Then we apply a forward bias in PN junction diode. Like these N types, P types, we get a plus bias, and N type we get a minus. We apply a minus bias. Then electron move to N type to P type, and holes move P type to N type. Then PN junction diodes junction boundary, it makes recombination, and recombination emit like energy like light. So if we wanna more if we wanna this diode has higher light efficiency, then we should make PN electron and holes stay more time in junction boundary. So we make potential well like this. So electron and hole stable more time, and then light efficiency is higher than before. Then we run the EK diagram and the direct band gap and the indirect band gap in semiconductor device 1. So we usually make direct band gap in this diode because direct band gap is emit energy more than indirect band gap, so light efficiency is higher. Okay. Second, OLED. OLED is O is organic materials, and we use this LED organic semiconductor. Organic and solid difference is solid materials is crystalline, and it's hard to fold, and it can make crack in materials, but organic materials is not crystalline, and it pours well like plastic. So we use OLED in smartphone like Galaxy Fold, but organic materials is not crystalline, so its mobility is lower than solid materials. Then organic materials, it exists like energy band and the state. We run the conduction band and conduction band and the valence band in these materials. LUMO is like conduction band, and HOMO is like a valence band. Then each gap is like energy band gap. Then each same in conduction band and energy gap. So each electron we get apply energy, then electron jump in LUMO to LUMO. So then in recombination, electron move to HOMO and it emits energy. Well, this second characterize is it each voluntarily voluntarily light emit light, so we don't we don't make color filter and color filter layer and background backlight model. So it's we can make a thinner device in device to use as OLED. So it's useful in this time. Then thin film transistor. This it require many things like black server and high mobility and low power. Then this is OLED display, and this bottom is glass. Glass is amorphous semiconductor, amorphous silicon. Then we learned about amorphous and crystalline and polycrystalline in semiconductor device 1. Amorphous device, we can't put crystalline structure up to amorphous materials. So we should use amorphous materials, but amorphous materials has low mobility. So more low mobility, then it makes driving current lower than before. Then it makes RC time delay is higher than before, so it's unusable. So we can we use polycrystalline materials, each LTPS. This each has more higher mobility than amorphous silicon, but it needs some temperature because glass. We makes this when we make this amorphous glass, then we makes we gather some energy, then this amorphous and this amorphous is has get some temperature and energy, then each change polycrystalline, so it makes temperature plus each off current is equal liquid current is higher, so we should use oxide semiconductor. Oxide semiconductor has higher mobility and low liquid current, so it's useful. Thank you.